The Romex hanging below the bat insulation is a violation of National Electrical Code Section 334.12 AM. National Electrical Code Section 334.103 addresses the use of non-metallic sheathed cable, often referred to as Romex, in specific environments. It states that conductors and cables installed in spaces conditioned at 5 degrees Celsius, which is 41 degrees Fahrenheit, to 30 degrees Celsius, which is 86 degrees Fahrenheit, shall be considered to be protected against physical damage where the conductors and cables are installed in a raceway or other enclosure, or were covered with thermal insulation having a minimum thickness of 50 mm, which is approximately 2 inches. In the scenario described, the Romex is not installed in a raceway or other enclosure. Furthermore, the thermal insulation is not covering the Romex. Therefore, according to National Electrical Code Section 334.103, the Romex is not considered to be protected against physical damage. The code emphasizes protection against physical damage to ensure the integrity and safety of the electrical system. If cables are exposed and not adequately protected, they are susceptible to damage from various sources such as rodents, accidental impacts, or other environmental factors. Such damage can compromise the insulation of the wires, leading to short circuits, electrical fires, or other hazardous situations. National Electrical Code Section 334.12 further reinforces this requirement by prohibiting the installation of Romex in locations where it is subject to physical damage unless it is installed in a raceway protected by metal plates or otherwise protected. In the given scenario, the Romex is not installed in a raceway or protected by metal plates. Therefore, its installation violates National Electrical Code Section 334.12 To clarify these code sections, it's essential to understand what constitutes adequate protection. Firstly, a raceway refers to an enclosed channel designed to hold wires, cables, or bus bars. Examples of raceways include conduits, electrical metallic tubing, and wireways. Installing Romex within a raceway provides a physical barrier that shields the cable from potential damage. Secondly, metal plates can be used to protect Romex in areas where it might be exposed to impacts or abrasion. These plates are typically made of steel or other durable metals and are installed over the cable to provide a protective shield. Thirdly, other forms of protection may include encasing the Romex in a protective sleeve or covering it with a layer of material that can withstand physical stress. The key is to ensure that the cable is adequately shielded from potential damage. In situations where Romex is installed in attics or other similar spaces, it is crucial to follow these guidelines to ensure compliance with the National Electrical Code and to maintain the safety of the electrical system. If the Romex is not installed in a raceway or otherwise protected, it should be relocated or protected to meet the code requirement. Furthermore, it's important to consider the specific conditions of the installation environment. Factors such as temperature, humidity, and the presence of corrosive substances can all affect the lifespan and performance of electrical cables. In harsh environments, it may be necessary to use more robust wiring methods or to provide additional protection to the cables. When working with electrical systems, it's always recommended to consult with a qualified electrician or electrical inspector to ensure that the installation meets all applicable codes and standards. These professionals have the knowledge and experience to assess the specific conditions of the installation and to recommend the appropriate wiring methods and protection measures. In summary, the Romex hanging below the bat insulation violates National Electrical Code Section 334.12 because it is not adequately protected against physical damage. To comply with the code, the Romex should be installed in a raceway, protected by metal plates, or otherwise protected to ensure its safety and integrity. Ignoring these code requirements can lead to hazardous conditions and potential electrical failures. It is critical to take these regulations seriously and ensure all electrical work is executed professionally and according to applicable standards. Consider an attic environment where the ambient temperature can fluctuate dramatically throughout the year. In the summer, attic temperatures can soar well above 86 degrees Fahrenheit, while in the winter they can drop below 41 degrees Fahrenheit. These extreme temperature variations can affect the performance and longevity of electrical cables. Therefore, it is essential to select cables that are rated for the specific temperature range of the installation environment. Furthermore, attics are often dusty and may contain other contaminants that can degrade the insulation of electrical cables over time. To prevent this, it is recommended to use cables that are specifically designed for use in harsh environments or to provide additional protection to the cables by installing them in a raceway or other enclosure. In addition to temperature and environmental factors, it is also essential to consider the potential for physical damage to the cables. Attics are often used for storage, and cables may be accidentally damaged by stored items or by people moving around in the attic. To prevent this, it is recommended to install cables in a location where they are less likely to be damaged or to provide additional protection to the cables by installing them in a raceway or other enclosure. When installing electrical cables in attics, it is also essential to follow all applicable codes and standards. The National Electrical Code provides specific requirements for the installation of electrical cables in attics, and it is important to be familiar with these requirements before beginning any electrical work. Firstly, all electrical work should be performed by a qualified electrician. Secondly, all electrical cables should be properly supported and secured. Thirdly, all electrical connections should be made in approved junction boxes. Fourthly, all electrical cables should be protected from physical damage. Fifthly, all electrical work should be inspected by a qualified electrical inspector. By following these guidelines, you can ensure that your electrical system is safe, reliable, and compliant with all applicable codes and standards. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician before beginning any electrical project. They can assess the specific conditions of your installation environment and recommend the appropriate wiring methods and protection measures to ensure the safety and integrity of your electrical system. The purpose of electrical codes is to standardize safe electrical practices. These codes are continuously updated to reflect the latest technologies and safety standards. Adhering to these codes ensures that electrical installations are performed correctly and safely, minimizing the risk of electrical hazards. In summary, Romex wiring hanging below bat insulation is a violation of National Electrical Code Section 334.12a and because it is not adequately protected against physical damage. To comply with the code, the Romex should be installed in a raceway, protected by metal plates, or otherwise protected to ensure its safety and integrity. It is also important to consider the specific conditions of the installation environment, such as temperature, humidity, and the potential for physical damage, when selecting wiring methods and protection measures. Always consult with a qualified electrician or electrical inspector before beginning any electrical work to ensure that your installation meets all applicable codes and standards. The National Electrical Code is a comprehensive set of guidelines for safe electrical installations. It covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. The National Electrical Code is updated every 3 years to reflect the latest technologies and safety standards. It is essential for anyone working with electrical systems to be familiar with the National Electrical Code and to follow its requirements to ensure the safety and integrity of their installations. The National Electrical Code is developed by the National Fire Protection Association, which is a non-profit organization that develops and publishes codes and standards for a wide range of fire, electrical, and life safety hazards. The National Fire Protection Association's mission is to reduce the worldwide burden of fire and other hazards on the quality of life by providing and advocating consensus codes and standards, research, training, and education. In addition to the National Electrical Code, there are also many other codes and standards that may apply to electrical installations depending on the specific location and application. These codes and standards may be developed by state and local governments as well as by industry organizations. It is important to be familiar with all applicable codes and standards before beginning any electrical work. Failure to comply with these codes and standards can result in fines, penalties, and even legal action. It can also create hazardous conditions that could lead to injury or death. Therefore, it is essential to take electrical safety seriously and to follow all applicable codes and standards when working with electrical systems. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and using tools that are properly insulated and grounded. It also means being aware of the potential hazards associated with electrical work and taking steps to minimize those risks. Firstly, always disconnect the power supply before working on any electrical equipment. Secondly, use a voltage tester to verify that the power is off before touching any wires or components. Thirdly, never work on electrical equipment while standing in water or on a wet surface. Fourthly, never overload electrical circuits or extension cords. Fifthly, never bypass safety devices such as fuses and circuit breakers. Sixthly, always use the correct type of wire and connectors for the application. Seventhly, always follow the manufacturer's instructions when installing electrical equipment. Eighthly, always have your electrical work inspected by a qualified electrical inspector. By following these safety tips, you can help to prevent electrical accidents and injuries. Remember, electrical safety is everyone's responsibility.